Hello students, in the last video we discussed critical angle and total internal reflection. So in this video we will talk about real and apparent depth, and this is the last topic of this chapter. Okay, so here is the image, this diagram we have to study. PQ is the surface, okay, and then this dotted line is water, okay, and then the above the surface we have air, rarer. So now our object is placed inside the water, okay, at certain depth, and we'll try to view that object from outside, like outside, that is air. From air you can say that is the rarer medium. So we'll see what actually happens. So for that we have to obviously pass rays from the object. So this is the object placed inside water at certain depth, okay. So first ray is this, it incidents normally, okay, at the surface. So normally if the ray incident, it passes undeviated, it goes undeviated, okay. You can see our second ray, it incidents at some angle, okay, at the surface, and obviously if it incidents at certain angle, so we will draw the normal, and normal is always 90 degree, it makes angle of 90 degree with the surface. So one thing I've told you, if water is over here and air is over here, water is a denser medium, air is a rarer medium. If the incident ray is in the denser medium, it goes to the rarer medium, it will bend away from the normal. This is the rule, we know this. So it goes over here in this direction, it should have gone something like this, but it goes away from the normal, it goes in this direction. So the person viewing from here, okay, this is the eye. So for him what actually happens, for him it will appear to him that the object is over here. For this person the object has raised above, okay, it has risen, okay, it appears to him over it, the object is at this point, okay. So the real depth was this, okay, this is the real depth, but it appears to him it is over here. So this becomes its apparent depth, that is the depth with what appears to him. So that is the apparent depth. Real depth is this thing. So this is real and apparent depth. Real depth is what actually the depth is, and apparent depth is what appears to the person, okay, viewing from outside. So this takes place because of refraction of light. You can see this is the phenomenon which has taken place. So now I'll talk about one more thing, that is shift, okay. So acha, before going to shift we'll discuss the this formula, that is refractive index of water with respect to air, that is real depth upon apparent depth, okay. So you can see an object placed in a denser medium when viewed from a rarer medium appears to be at a depth less than its real depth. This is because of refraction of light, okay. So obviously this is what I've explained it to you. So now one more thing we'll talk about, that is shift, okay. So what is shift? So now you can see what has actually happened is this object was over here, now it appears to us viewing from outside that it is placed over here. So what has actually happened, it has shifted from here to here. So this is known as shift. So how do we calculate shift? This is the shift. So how do we calculate this shift can be calculated, this is the real depth, okay. If we minus the real depth with the apparent depth, this is the apparent depth, so what we'll get this thing, this is known as our shift. This is the shift. So shift is real depth minus apparent depth. And then there is one more formula, this is used in the numerical, that shift equals to real depth into 1 minus 1 upon refractive index. This mu denotes refractive index, okay. So this is the concept of real and apparent depth, okay. So now I'll tell you numericals related with real and apparent depth, okay. So our first numerical, a water pond appears to be 3 meter deep if the refractive index of water is 4 upon 3, find the actual depth of the water. So actual depth means what? Real depth we have to find out. Okay, a water pond appears to be 3 meter deep. Appears means, I've told you, appears means this is the apparent depth. Okay, so apparent depth is given as 3 meters, and refractive index of water with respect to air is 4 upon 3. So real depth we have to calculate. The formula is real depth upon apparent depth. So by using this formula, refractive index of water with respect to air into apparent depth, okay, this will be cross multiplied, you will get the real depth. So we will substitute the value 4 by 3 into apparent depth is what? 3. So you will cancel this thing out, so you will get real depth as 4 meter. So this is the actual depth. This is a very simple numerical. Okay, these are even asked in your exam, but the problem comes when we talk about the numerical based on shift. I don't know why people find it difficult, but it's very simple. Okay, so let us see a numerical based on shift. Sorry. A postage stamp kept below a rectangular glass block of refractive index 1.5 when viewed from vertically above it appears to be raised by 7 millimeter. Calculate the thickness of the glass block. So a stamp is kept below a rectangular glass block. This we can see, I've drawn this rectangular glass block. It is kept somewhat over here, okay, below it. So a refractive index of glass they have given 1.5 when viewed from vertically above it appears to be raised. It appears to be raised by 7 millimeter. Calculate the thickness of the glass block. Okay, so we know this is going to be our real depth, this is going to be the apparent depth. Okay, it has risen by 7 millimeter. So we know what is 7 millimeter in this case. 7 millimeter is the shift, and we know the formula. Shift equals to real depth into 1 minus 1 upon refractive index. So in this case you have to assume, obviously we have to calculate the real depth. So let the real depth be x. Okay, so 7, shift is 7. Okay, 7 equals to real depth, we have taken it as x. Okay, sorry, I'll tell this I'll again tell this thing. So shift is actually real depth into 1 minus 1 upon mu. So we'll substitute the value 7. Shift is 7 and real depth is x. So into 1 minus 1 upon mu. Refractive index in the question is given as 1.5. Okay, so now we'll solve this. 7 equals to x. Then while solving this, so 0.5 upon 1.5, so you can cancel out the decimal. This becomes, we'll take this value this side, 15 into 7 upon 5. Okay, so this comes out to be 21 millimeter. Means 21 millimeter is the apparent depth. Sorry, that is our real depth. Okay, that was asked in the question. Calculate the thickness of the glass block. So now you can see one thing. Real depth is the same thing, that is going to be the thickness of the glass block. Okay, this is the real depth and this is going to be the thickness. This is nothing but the thickness. They are just trying to confuse us. Okay, and one more thing that is not asked in the question, but one thing you can see, and if this is the shift, the stamp was kept over here, so the real depth is, that is the thickness of the glass block is 21 millimeter. This we have calculated. So one more thing you can calculate, the apparent depth. Okay, what it appears to us. Okay, obviously that will be 21 minus 7. You will get this thing, the apparent depth. Okay, that's it for today. Thank you.